Today is the second day, and today we are going to go through this valid anagram problem. In what is an anagram? They have given us two string. If all the characters which are present in first string is present in the second string as well, then they are anagrams. See here, A is present thrice, N is present one, G is present once, R once, M once. So these are two. For example, and in the second part they have rat and car. R is present twice, both here and there. A is present, but here we contains an extra T which is absent here. So this is returning false. The constants is both are lowercase. S and T are lowercase. This will consider this by default. Okay, so we have to find the optimal solution. So how can we solve this problem? So first of all, anyhow, since it is a string, we have to compare the string length. If both the string lengths are equal, if it is not equal, then they are not anagrams. So the first thing is like, if s dot length is not equal to t dot length, then for sure return false. These are not anagrams. Okay, so what can we do next? String is equal. What we can do is like, we can save this string into a character array. We will take two character array, s short equal to s dot, we in C# we have this 2char array. This will convert this array into a string. This convert this string into an array. And one more is t short t dot 2char array. Okay, so we have converted a string into a consecutive arrays. After that, what we have to do, we have to sort this array dot short s short and array dot short, sorry, this will be smaller here, and second is t short. So we have sorted the array now. Now we have to see like both the arrays are exactly equal or not. So how can we check that? Return s short dot, see, there is a method called sequence all. T short. Okay, if this returns true, this is a valid anagram. If it returns false, then this is not a valid anagram. So I'll try to run this. Sequence all, no, sorry, sequence equal. My mistake. Thanks. This is done. Memory is 44 something, 67 MB. So here what are we doing? We are converting this string into a character array. So two character arrays are there, and plus we are sorting it. If we consider the best case, then also for sorting, the best case is like it takes n log n of time memory, n log n for sorting, and then we are comparing. So this, and we are occupying two arrays, that also memory is double. So this is not the best way to solve this problem. Sorting is okay, but memory is twice. So how can we achieve this if there are any other way to solve the same problem? So what can we try next? Next we can try is we can create two dictionary and just see if the dictionaries are equal or not. This is the most common way of solving this problem. Dictionary will create two dictionary. We'll save the characters. One dictionary for the S. Similarly, we need one more dictionary for T. Dictionary char int count T is equal to new dictionary char int. Okay, advantage is we have to loop only once because length is equal. So for int I equal to 0, I less than s dot length I plus plus. Okay, so we are looping this first string and we have to insert this value into this. So count s of I. Okay, whatever t will go first, then I, like that you have to loop one. So what we are going to do, we have to do if we have to read whatever is there in that key and we have to increment it plus 1. The problem of this, if it is not there, then it will throw a null exception. The key is not defined. So in that case, we can do one thing is like these are variables, we have to make it smaller case. These are variables. Variables should not be capital case. So here if the dictionary, the key is not defined, it will throw a null exception. So what we can do is like get value or default. So if value is there, it will give you the value. If it is not there, then it will give you the default 0 value. Okay, similarly we have to write this for T also. Count T of I is equal to count T get value or default. T of I, if it is there, if it is not there, then 0. Okay, so we have filled the dictionary. Now we have to see the dictionaries are exactly equal or not. That's it. Means we have to see if both the dictionaries contain exactly same number of characters. If both the dictionaries contain exactly same of the characters, and there should not be, means whatever is present in S should be present in T. Count S dot except if anything is extra there in count T dot anything extra, it should be nothing is extra, nothing is not true, it should be false, nothing is there. So if this is true and this is true, then this is a valid anagram. Cannot apply get value or default. Sorry, cannot apply indexing with to an expression of type M. Method group. Oh sorry, this is a method. My mistake. Yeah, done. Oh, capital. But here then also this problem is there because we are using two dictionaries. We are filling two dictionaries, so the space is relatively very high. If we can reduce the space somehow. Now, can we achieve this by reducing the space still? So what can we do next? We can't use dictionary. We are taking two. What we can do is like, we can see the third method we can try is like, we have to reduce the amount of space. What we can do is like, we can create an integer array count. This will store the so if you know, like there are 26 characters in a alphabet, English alphabet. So considering like the string is always small case, so since there are 26 characters, so what are we going to do is like, first we'll take for example bat and car and cat, so we'll take the C. Okay, so I'll first write the code, then I'll try to explain this. So first what we have to do is like int I equal to 0, I is less than s dot length, because we have to root this, I plus plus. Okay, we are looping this array. Now what we are going to do is like count, we have to fill this count s of I. Okay, every character we have to position it, like for example C is there, so A starts from 97 ASCII character, so C will be 97, 98, 99 characters. So we have to keep that, we have to give an index for every character. So how are we going to do count of s of I? Okay, for example C, so we have to deduct this with A. So C and minus 97, so C means 97, 98, 99, so it will be 2, that kind of. We'll index every character and we'll add here plus 1. Similarly, we'll read the second thing. Sorry. Count T of I. We'll read this and we'll same way we'll do minus A, and if it is present, then we'll deduct this. So ultimately, for example, C cat, C car. So the first line will go to the third position, fill it plus 1. And since T is the car, again it starts with C, it will go to that pair -1. So ultimately that index of the value will be 0. So after filling this, we just have to see like all the 26 characters in that array should have 0. If it is not there, then it is incorrect. Int val in count will loop this. If val is not equal to 0, anything is not equal to 0, then return false. These are not anagram. Okay, and if otherwise, return true. This is a valid anagram. So run this. So here we have worked on the space part for each. Sorry. We have worked on the space part here. System.index out of index was outside the bound. For each val in count, what index in I equal to 0? S dot length I plus. Oh, sorry. This is exactly same. Where exactly it is causing the mistake? S dot length, T dot length return false. Count we have kept. We are looping each and array. We can do this. You can simplify this with this. You don't have to write like this. Count of base of I minus age. Whatever is there, just increase +1, and whatever is there, decreases 1. Done. So here we have worked on the space complexity also. We are just using an array, and this is the best solution for solving this problem. Thanks.